In large enterprise deployments, you'll probably have different programs serving each of the networking services that we covered in this module. In smaller setups, you may be better off having a centralized solution that handles all services. Let's look at Dnsmasq, a program that provides DNS, DHCP, TFTP, and PXE services in a simple package. This will let us do some hands-on configuration of these services, even if it's not as complex as other networking solutions. Let's start by installing Dnsmasq in this machine. So I'm going to type in sudo apt install Dnsmasq. Once we've installed Dnsmasq, it's immediately enabled with the most basic functionality. It provides a cache for DNS queries. This means that you can make DNS requests to it, and it'll remember the answers so your machine doesn't need to ask an external DNS server each time you make the query. In order to check this functionality, we'll use the dig command, which lets us query DNS servers and see their answers. So let's ask our DNS server running in localhost for the address of www.example.com. We do this by running dig www.example.com at localhost. The part after the @ sign indicates which DNS server we want to use. Here, we have the reply from our query. Our DNS server is telling us the IP address for the domain example.com. How do we know that this query was actually answered by the service the machine is running? We can run the service in debug mode so we get more information about what's going on behind the scenes. This isn't how you would normally run the service, but it's useful for understanding what's happening. So let's stop the Dnsmasq service that's running and then start it in debug mode. So now I'm going to type in sudo service Dnsmasq stop. Then type in sudo Dnsmasq with the D flag and then pass the Q flag. By passing D and Q, we're telling Dnsmasq that we want to run it in debug mode and that we want it to log the queries that we execute. When it starts, it prints in the compilation options that are enabled and the configuration files that are used. Now, we can query it again with our friendly dig command. If we run the command again, we'll get the same answer and we'll see the debug output in the Dnsmasq console. So in my second console now, I'm going to go ahead and type in dig www.example.com at localhost. This is showing us that our Dnsmasq service received the query, forwarded it to the configured DNS server, and then replied to the original machine. If we query for the same hostname again, we'll see that instead of asking the other DNS server, Dnsmasq replies with the cached query. So now my second console, I'm going to type in, again, dig www.example.com at localhost. So if I hit enter, for now, Dnsmasq is operating as a simple caching DNS server, but we can make it do more than that. For example, we can give it a list of hostnames and IPs and have this service give authoritative answers for them. You might remember that when trying to resolve a host name to an IP, there can be servers that store the information about the mappings, which can then provide the authoritative answers, while other servers will only be able to forward and delegate the queries to the server that had the information. These files have the same format as the etc host file. I've created this file that lists the internal host that I want to be able to resolve. So I'm going to type in cat myhost. As you see, it's a very simple format. You just have to list which IP is associated with each host. We use the H parameter to tell us Dnsmasq that we want to include this list in the information being served. So I'm going to cancel this, clear. And now I'm going to type in sudo Dnsmasq dq h my host. Now that we have our list of hosts loaded, let's query it with dig. So now, on my second console, I'm going to type in dig oxygen.local at localhost. As Dnsmasq is authoritative about this host, there's nobody to forward the question to. It also lists which file it's using to get the information. Neat, right? Finally, let's see what the output looks like when we ask it for information that it doesn't have. So I'm going to type in dig hydrogen dot local at localhost. We see that it replied that the authoritative servers are the root servers, but that it couldn't find any results. And what did the running Dnsmasq say? Since the requested name isn't in the list of hosts known to our DNS server, it forwarded the query to the configured DNS server. The reply for that was nx domain, which means non-existent domain. While Dnsmasq is as simple as it gets, you've now seen what a DNS server looks like in action. Cool, right?